speaker, Mikhail Zotyev. Mikhail will guide us Flutter under the hood, exploring the important internal workings, inner trees, pipelines, and other hidden mechanisms that Flutter make Flutter so efficient and convenient to use. A must for any Flutter developer. Welcome, dear Mikhail, waiting for your amazing talk. Flutter under the hood.
Yes, thank you, Anna. Let's start our today's discussion, and I'm happy to offer you a topic of how our code is converted to pixels, which users usually see on their screens. How Flutter does it actually, because there is a lot of work between we write a simple description of what we want to show and the user actually starting to see it. And let's start with a short introduction. I will talk a bit about myself. So my name is Mikhail Zotyev. I'm Flutter and GD, an organizer of another meetup community, which is called Flutter Voronezh. Also, I'm really like open source and support it, including my own packages and other projects, including Flutter. And I have educational channel about Flutter, Oh My Flutter. You're welcome to join it. And as professional activity, I'm a senior software engineer at Volt. So you can see on the slide my nickname, which you can use to find me in any social network that you personally prefer, and I registered there. So let's get the party started. And when people describe Flutter, during the time it was always different description. First of all, it was declarative UI framework, something like this. Then it was cross-platform UI framework. Currently, it's more used description of multi-platform. And I think current description is highlights the most important thing. Flutter can support us with write once code and run on any platform that you actually want. We have the supported from the box mobile platforms, web, 3 desktops embedded, and even if something is not supported, you can do some work and make Flutter run on some platform that it's not yet supported. For example, you can check out Sasha Denisov's talk about running Flutter on Apple TV and Android TV. So even without official support, you can run it. And the only requirement is to have a screen. If we visit a Flutter website, there are also usually different marketing quotes, and they are also changing time after time. But one of my favorite was control every pixel on the screen, because Flutter actually does it. And when I think about this statement, like control every pixel, is quite a complicated thing. I immediately image in my head something like the cockpit in the plane. So a lot of switchers, lights, and so on, and you need to know so many things to properly control it that it's should be complicated topic. But Flutter is opposite. Flutter really friendly to start work with this, because the requirements is just use use a widget to describe what you want. So it's another strong side of Flutter, being declarative framework. So it's sharp to be a good tool for just describe, I want to see this, and actually get this. But like to understand what it does mean, be declarative UI framework, we need to first understand how to build UI in general, not about Flutter. So if I want to describe some UI, I would like to answer three questions. First of all, what to show, for example, is it button, label, input, or whatever else? Uh, where to show, how they connected to each other, how they related to each other, like what inside, which object inside of which objects, what contains what. And the third question is how to show, which size, maybe position or something else. So all those questions describe what we want to show to the user. And in Flutter, there are three responsibilities which actually answer those questions: widget, element, and render object. We will go through them one by one and check what is it. And we will start, of course, with the widget. Even if you started work with Flutter yesterday, you definitely know a quote, it's all widgets. And yeah, even we said already that there are something apart from widget. It's actually true, because even if we create our own render objects, elements, and so on, we do not directly operate with them. We anyway need to work with them through widget. So widget is a central class in the Flutter framework. But apart from that, what it is else? The good way to discover this is just checking documentation of widget. And the first thing which we will see then, that it's immutable description of part of a user interface. And this is already things which can be questionable. So people can say that we have a mutable thing in stateful widget. We have a mutable thing which calls state. Yeah, it's true. But state is a separate data guide. It's not related to widget at all. Widget creates state, but after this, it's not somehow managed. State is related more to element than to widget. So widget by itself, it's still immutable. Even stateful widget is immutable. And second thing, again, in general, we can fairly say that user interface by itself is not immutable. I mean, it's not static. It's always changing. It's quite dynamic thing. So we have a lot of animation, changing color, changing content on the screen. For example, the part of user interface can disappear on the place, can appear and other things, and so on. But what if we take the whole time and separate it to small time ranges, so small that we can say that they are that immediate time, the moment. And this moment, any user interface is static. It's just a frame which we are showing to the user exactly this in this time. And that's exactly what makes Flutter able to operate with immutable objects to describe those things. Because Flutter continuously asking, preparing new frame and showing it, and do it this 120 times per second. So because of this concept, we can say that we can operate with immutable description. We can create a widget and insert this many times or not included into the tree at all. Since they are immutable, they are lightweight, don't have a life cycle, and every time when we place it somewhere, we create an element. So a good example or analogy from the real life for widget would be a blueprint. So we once described what we want to have. We define how it should be, what's parts there, and so on. And then using this blueprint, we can create as many objects as we want. So let's prove it and make something that we usually don't do in normal development with a Flutter. But it's a good experiment, and we will do this many times today. So we have a widget, just a stateless widget which returns text hello world. And we can create variable. And in this variable, we put this widget, one instance. And we use this one instance 4 times. So if we run this code, we will see 4 times hello world. So every time we just used the blueprint to create a subtree which described by this blueprint. It's because every time we use it, we create already real object, which is work behind the scene, which is called element. And element is just an instantiation, a representation of what we wanted to show, particularly in a concrete place. And since they are already real objects, but not only intend to show something, so they form a tree with a relation between nodes. They have a life cycle because they already not immutable and abstract intention to show something. They are exist and can change, something happen to them, and so on. So life cycle is important. And during this life cycle, many things can happen. And because of this, associated widget can change. So element more stable than widget. Because of this, element can rebind to another widget if it's possible, of course. And widget is life cycle of element from creation to time when we're destroying element. It can follow the different stages. First of all, we need to create, of course, and widget is responsible for this because who apart from widget knows how to represent it. So create element method which widget used to create a representation that's element. And after we create this, we need somehow insert into the tree because creation is just a new object. So mount is a method which is called on element also to connect them with some existing element and bind the links relation between those elements, build a tree. So after this, we can say that user already can see something on the screen when it's happened. After, of course, frame is finished. But between those frames, something can change, and element can be marked like this part of UI should be changed, updated somehow. And this came to updating. During updating, there are possible scenario that we keep the same thing. We just update status of those subtree, change one the values, for example, or something, or completely replace subtree with another subtree. So can update method from widget helps when we run updating child, when Flutter run updating child on element to decide how to manage those things. And if we decide that this subtree is not necessary anymore, at least for now, deactivation has happened. So element and all subtree behind this element is moving away from the actual tree. And for every node, deactivate is calling. But it's not destroying here because before the finish of the frame building, can happen that someone decide to reuse those subtree in a separate place in another part of our UI. It's happening usually when there is a global key on those subtree. And in this case, this inactive subtree can be moved back to actual work and calling activate on those things. And if at the end of the frame we do not reused subtrees, there are something that we removed but not reused, they will be actually destroyed with the calling unmount and disposing on them. When we talk about element, it's also important to highlight this concept as a build context. So actually build context is just element, not everything, but the contract implemented by element. With this contract, we highlight things that should be used and hide things that should not be used and should not be manipulated. So internal things is hiding, and something that's important to understand when we're building subtree is oppositely highlighted. Even the name build context means that we want to build some tree somewhere and we need to understand where to build. So this is a context which allows us to understand what is the location in the tree and interact with this tree properly. Why it's can be helpful at all. So let's figure out another example from the real life. For example, we have a blueprint of a propeller. Yeah, just spinning thing around the axis. And based on how we place it and where we place it, it can be quite a different way of using. For example, if we just put this propeller in front of me and turn it on, it will be a cooler, which will help me if it's too warm. But if I put this into a container and additionally put the ice cream, milk, and so on, it will be a mixer or blender. So the same thing works differently in different conditions. The same with the Flutter widget. So again, example with the putting thing, our widget into variable and using it in different place. So widget by itself, quite simple. It's just a container with a primary color of the theme and size of 100 to 100. So, and if we run this, we see that exactly the same instance, which is based in different places, works differently. It's happened because this blueprint widget intention to show put some subtrees. When we create, when we insert it, it's represented to element. But then when we need to describe what is this exactly, we call a build method. Flutter call build method for us and provide element here. And with this element, we will find a different environment. And because of this different environment, behavior, even the same instance, can be different. And the good time for, again, go back to state, which we already briefly discussed. So when we have a stateful widget, one-off widget, which is quite often used. So we always create the method which is called create state. And this is the only place when we actually interact from widget with a state to state. So state to widget we can reach in any time, but this is the only time when we do it oppositely from widget to state. Because it's full delegation of everything that happened next to this special object state. And so if we do exactly the same thing and create one variable in which will be instance of one widget, which is stateful widget currently, and this state actually changing color when we click on those place on those subtree. So if we place it here, they be completely independent from each other because it's just only intention to put the subtrees controlled by this state, and we can click on a different part of those things and they will be work separately, because when we place it, we ask that it will be controlled by this delegate. And for every time when we place it into the tree, return it from build method, element will be created. And with this element, state will be created, a separate instance of state. So after this, element knows about who created. State knows with which widget it's connected. All of them, they know about this widget, but widget doesn't know about them. And all elements based on those things can be separated in two big groups. Composition elements or component elements, those who delegate to other widgets, compose other widgets together to describe what is the subtree. So they don't actually show something by their own. They just manage other things together. Such elements and widget like stateless, stateful, inherited, and the good sign that this is this type of widget, that there is a method which called build, and it should return widget. So the widget by itself, following this concept, is just returning another widgets which will describe the subtree. And opposite to them, there are render objects. Widget, the render objects element, and widget in this case usually has another method, which is called create render object. And they are usually something that we show to the user or somehow change a layout for showing. For example, padding, column, or something like this. Let's say smallest part of our UIs usually is this type of widgets and elements. And based on those two things, there is important concept in the Flutter that's called aggressive composability. So the idea of this concept is that every widget can be a widget that just use another widget and composing them together. And those other widgets, they also can be the same type of widgets. They just going smaller and smaller and smaller. But anyway, in the end of this subtree, we will finish with at least one render object widgets. So yeah, based on this concept, we always build our way how we work with the describing user interface and describing subtrees. So we mentioned that there is render objects, and actually this is a special object which implements layout and paints protocol. But also important to highlight that it's just implementing those protocols. They do not actually paint anything. They do not actually rendering anything. It's happening in a completely separate place. They are just calculate what should happen. Then they form this into some description. And by this description, actually painting, rendering engine will do its work. And this render object is kind of free how it can be implemented. So it can be different child models, so it can be without child at all, has one child or many children, can be different coordinate system, Cartesian, or if you want to, you can implement even your own specific protocol. Also, there is no rules. So the only rule that's based on constraint, you should provide a geometry. But layout protocol can be various. For example, it can be box protocol for normal layouting, or sliver protocol for scrolling, or you can create your own protocol if you really want to cover some requirement for your widget. So if sum it up, there is these three responsibilities which together work for describing UI. So declaration, what we want to show and what it should be. Then actually connecting them with each other, and layouting, showing what is showing and appearing where. And when we call about those three things, widget, element, render object, people quite often use a word tree. And since we in a technical area, programming, so everything that we properly name, that's have behind this name some meaning. So tree usually in such things is a tree from graph theory. So it's a undirected graph. Two vertices can be connected with only one path, and there is no cycles, there is no loops, and so on. And here's the tricky thing. So when we say widget tree, and check example that we already have seen, which I offered in the really beginning. So we create one node, one variable, and use it many times. It's do not match with a tree at all, because the one node somehow inserted twice at least. So how many possible times? So how it's possible? Because widget tree is not actually a tree; it's just a simplification. Simplification to avoid additional concept or something. So this is a structure, declarative structure, which can be converted to the tree, and it's actually converting to the tree because we build a real element tree, which follow the all rules of normal tree of graph theory. But it's help us to easier explain what we work with. And let's try to just build those trees as Flutter usually does it when we try to insert this. So let's imagine that someone returned this widget in some place. So quite simple widget. We get text as a parameter and return container with a specific color, specific size, and put this text string which we take into the text, showing this to user. So this is our structure that we expect, what we know that exists. So when we insert this, Flutter asks my widget how to represent it. And this is a stateless element representing it. Stateless element connecting with the element above. Have a link to a widget created this, and this is not render object. So there is no render object, and we need just build a subtree. Because of this, stateless element asks to build my widget. And it's returning those structure that we described, container and text. So the next node to check is a container. So Flutter asks to represent container itself, and it's again stateless element. They are connected with each other with a previous element, has a link to container, and again there is no render object. It's just a composition subtree. So stateless element asks container to build the actual subtree, and even if we write in our code it's just wrapping text, container by itself is also quite complicated widget which has a logic behind. So the structure which will happen is just container box, colored box wrapping around our text widget. So the next step will be asking constrained box, what is the representation? This is single child render object element, because we need to set a size of this part. Because of this, this element, after connecting and have a link to widget, it will ask, and what the render object then? Create a render object. A render object is render constrained box. So this object is already inserted into the render object trees and connecting with the render object above. So after this, we go to the next step. And for colored box, again, created a representation as a single child render object element, which is connecting. And again, it requires to have a render object. So element will ask widget to create render object. And when it's created, we have a connection between those render object, and element has links to both of them, and render object and the widget by itself. So the next step is a text. And when Flutter asks text about representation, it's also stateless element. So there is no render object, even if by the name and the meaning it's text, it's still just a description of a subtree. So we need to build. And after build, we can see that there is a rich text inside, which will be actually the end of our subtree. So we ask this rich text about the representation, has element, connect with a other element, and has a links. And this element already will ask rich text about render object. And this way, as we expected, that we wrap up everything as an aggressive composability, we finish with render object. in the end. So this subtree described by this combination of different objects. So we mentioned previously, we discussed that there is a build context, and build context is interface for each of elements. And in the build context, there is a method, getter, to be accurate, which called is render object, and it should return render object associated with the concrete element. But what's happened if we ask, for example, from the top element which doesn't have any render object to return render object? So again, due to aggressive composability, we know that down by the trees there is at least one render object, and we can utilize it and just go down by the tree and trying to find at least one this element which has render object. And after this, we can just return this, and we will know that this is the first render object that is represented for this subtree. But we discussed how it's happened when we create. Sorry, one moment. When we create subtree. But what happened when we update subtree? And there are three possible scenarios. So we will have the same instance of widget, we will have the same type of widget, and we will have a structural changes, and they quite different and different level of performance expensiveness. For example, let's check the case when we have a subtree, it's already built, and this stateless element becomes marked as a need to be rebuilt, and as a widget which currently should represent it, it's the same instance of a widget that it was before. For example, if we use the constant object, or if we return exactly the same cached instance which we manually did. So in this case, stateless element just check and say, okay, it's exactly the same instance. So there is not possible that any things could change behind those level, that it will be exactly the same. We will not even build anything. So we will stop on those steps. This more efficient way, that's why constant quite often helps with the performance. But if not, if it's not the same instance of widget, we need to decide, is it possible to update with a new widget, new intention to show something, or it's not? And here is a method which usually plays for this. Can update. So we check if two widgets have the same runtime type and have the same keys. If it's possible, so we can update. If not, we cannot update with this tree because it's changing something. So let's check the first thing. First of all, again, our top level element is marked to be updated. So, and the new instance of widget is my widget, the same type, but different instance. So stateless element check the previously widget is my widget, current widget, my widget. So we can continue. It's a composition. So we just call a build and get the structure and go to the next step. Again, next, container and container can be updated. Need to be built. Building structure and get new instances, which will be described below subtrees. So single child render object element, check constrained box and constrained box can be updated. And then, since it's a render object element, it's check the property of this, for example, size, something like this. If it's the same, it's don't do anything and just continue. The same with the next step, checking colored box with colored box, just updating a link and check the property. If property doesn't change, doesn't update. If change, it will be update here in render object. And the next thing is text, also another instance. instance with even another text, for example, text B, apart from previous text A. So the thing is just type of widget is the same, text, and it will be updated. And because of this, it will be asking for build subtree. And in this case, it will be rich text with another text B. So single child render object element at the bottom will check, is it possible to update? Yes, it's possible. But then we can see that it was a text A before update, and now it's text B. And because of this, we need to update render paragraph as well. So after this, updating happened, and all our previous structure is not necessary anymore. And we finishing update this part. But apart from this, it can happen that we change structure. And in this case, it can be more complicated. And sometimes we even can change structure accidentally without proper intention to do this. Let's check this example. For example, we add to previous widget additional parameter, which is color, can be nullable. And we pass this color to container. And initially we have, for example, this subtree. So instance with the color red. And after update, we say that it should be instance B with the color null. So what happened there? As previously, we just checking, is it possible to update? Possible update? Yeah, the same the same type of widget can be. Build subtree and check for the next node. Stateless element, container can be update, and build subtree. And after this, we're checking this part. So single child render object element, constrained box, and constrained box. Updating and updating render object is necessary, not necessary in our case. And after this, we can see that it was single child render object element connected with a colored box, but text is a completely different widget. We cannot update it's work differently. There is no sense to make this update. Because of this, everything starting from this point is removing, and we need continue building from scratch. So creating a representation, make a build, create another representation, create a render object. So as you can see, there are many works comparing with the previous cases. So that's mean every time when we changing structure, it's more expensive. It's almost building from scratch. The same amount of work for building when we don't have any widget at all, don't have any structure at all. I mean, we didn't insert before anything. And also in those methods which we use for checking is it possible to update or not, there are keys which describe as a part of checking, like we checking, do they actually the same or not, for understanding can we update this part subtree or not. So keys, they are special object which can identify subtrees. So they all can be separated to two big groups. Local keys, which works on the same level. For example, you have a few objects inside the column or scrollable area and so on. And if you want to sort them, remove something in the middle, and be sure that they will be properly identified, which was removed or not. So in this case, local key is a good way to solve this problem. And the global key is a more complicated thing. Global key is highlighting a unique part of subtree, which is unique for the whole application. So because of this, it's from one side bring you additional opportunity. For example, you can directly ask using this key, interact with this subtree directly. For example, reach out to element, render object, or whatever else. And from another side, it's additionally requires a lot of to be accurate with this, because you can easily face it with the situation that you insert unique things twice, and it will be a problem. It will be error. So also this global key, they use a mechanism that we briefly touched already, is reusing. So with this mechanism of reusing, the whole part of subtrees can be moved to a separate place in the application. For example, moving from one part of UI to completely another part of UI with the keeping all internal state that is exists there. But it's can be also really expensive, because if this subtree is huge, for deactivating, Flutter will go through all nodes and call deactivate, and then when we reuse, it's go again and call activate for each of them, which is can be really expensive. But all those things which we discussed before now, uh, they related to quite abstract thing, like small subtrees, but almost we discussing they are working in nowhere, but they work in a special place which called Flutter application. And to understand how it completely work, we need to understand how Flutter works. And to explain this, we need architectural overview. So the whole Flutter application can be and the Flutter framework can be separated into three layers. First of all, embedded layer, which related to platform and make Flutter works in the concrete platform. Then we have an engine, the heart of our framework, which manage everything, control everything, and do the actually managing work. So here also a rendering engine. That's mean that when we already showing to the user something, it's happened exactly here, despite we working in this part. And framework layer, on top of which we built our application already. It's written in Dart, provide us with different libraries, UI libraries, Material, Cupertino, default simplest implementation of widget on which we can also base everything, rendering, animation, and so on. So if simplify all processes that happen inside, we can say that somehow engine periodically ask framework part like what to show to the user when the platform is ready to show something, and the framework answer with the description what to show, and this description is already converting to pixel and render engine and showing to the user. And it's happened 120 times per second, so quite a lot. But of course, when engine asks about this, it's asked not whole framework, because it's could be really spread responsibility in this case. To connect our part and the framework part of Flutter with engine, there is a foundation layer in the framework layer of framework. And this foundation layer does this work for us. Let's check it. And entry point for us will be a method which we use for running application. Previously, I would say this is only method, but now there are two of them, run app or run widget. The preferable, of course, run app, as it previously was. A difference between them that run app is wrapping application, so the top level abstraction of what you want to show to the user, the whole application, with the default implementation of connecting with the views or in this case, you can manually care about those things. And in both cases, we operate with something that's called Flutter widget bindings, which is combination of mixin, which call binding. And every binding is just a glue with a connecting between engine and in some area. For example, in heat testing or in preparing frames, in working with accessibility. And they together, they do all those managing work on the framework side, which is required for engine currently. So since it's mixins, the order in which they are connected, it's really important. So because of this, ordering guarantee that the request of handling and preparing frame will be handled by special places in the special order. So let's check the new method, which was maybe 1 year ago added only, this run widget. So in this case, we need to care by our own, and I don't know, to be honest, better way to do that. Just use the previous implementation. Just use a render object to widget adapter, which will create the, let's say, 3 root objects, like root widget, root element, and root render object, which will be managed by special owners. And that's way guaranteed that everything will work. Or current, more preferable way, that's make those things automatically and with a more fresh structure, let's say this way. So it will be more layers between those things, but anyway, it's exactly the same work. So they just created a 3 roots thing, which will be managed by owners, pipeline owner and build owner. And in both cases, we have operating with the binding. So schedule attach root widget and schedule warm-up frame. So schedule attach root widget is actually another wrap around our application that we provided. So yeah, currently it's more complicated than it was, for example, 2 years before, when it was just three objects which created. Now it's times more complicated. We additionally to those wrap which we created automatically on manually add root widget and root element. So to simplify all those things, it can be say that in any way we create those structure, our application and 3 root objects. And after we did this, schedule warm-up frame is running. So what it's this widget, this method, and why do we need it? As we previously already briefly discussed, so building from scratch is more complicated than updating small pieces of UI that's changed. But when we starting application, we don't have anything yet, right? So we need to go through all those abstractions starting from the application that we provided, and before we finish all those things. And because of this, it's more work than actually any other frame will be handled. And because of this, it's starting earlier and preparing what to show before we signal the signal of that platform is ready to show something happened. And it saves additionally milliseconds maybe, but it helps running more smoothly than before. So yeah, all other frames will be prepared because of we sync tasks. So even if we have a complicated huge app, around our huge app there will be also a really huge construction which works our code. It will connect our code with all things from engine. It will manage our code and control it. So this is why Flutter is actually framework. So it's not framework because it's big or something. It's framework because it's control our code, and we do not control Flutter code. But apart from the all-time preparing frame also built through few important steps. Every frame goes through them. First of all, it's updating animation to have actual values in those animation, running micro tasks to have everything done before we prepare frame. Then it's building updated part of our subtrees, layouting if it's necessary, composition, paint in the meaning of description what to paint, because then we composing everything to a special object to send it to engine. Update semantic and cleaning phases of the frame. So every frame to show the small picture, not small picture, the whole picture, but for really small time, following this important many steps. And few steps of those, like build and finalization build, they are controlled by build owner. Build owner track what need to be rebuilt. It's manage inactive elements which was removed. It's handle hot reload. So important methods from it: schedule build for scheduling what will be rebuilt. Build scope is actually rebuilding. That's this method which run for every hour widgets that need to be rebuilt. This rebuilding process. Finalization for cleaning, and reassemble for make hot reload possible. And when schedule building get the request from engine that it's need to be prepared because of order of adding mixins together, we can see that this request will come here in widget bindings draw frame, and we will see here those two steps: build scope, building, and finalizing. So between those two things happen everything. How happen rebuild? So rebuild is called on element, and it can be called from three places. Build owner can call this. It can be during first insert into the tree or when update. And every rebuild depends on the type of element or type of widget. So if it's a render object widget, render object element, it's just updating a property for render object. If it's composition component element, it will be rebuilding subtree, and during rebuild it can be rather inserting or updating. And the only place which is not wrapped up here is build scope. So it's a place from which we initiate our rebuilding start. And since it's holding the list which is managed by schedule build for method, so schedule build for is adding to the list of updates. So it can happen when deactivation to activation happened, or when element is marked to need to be rebuilt. So during upstarting, set state, for example, hot reload, or when dependency changed for element. For example, when we use depends on inherited widgets. So quite often when you operate with a dot of context, it's a subscription on changes, and this is also causing those rebuild. So between those two steps, like building and finalizing, there is only one, apart from assert, there is only one call, super draw frame. And when I say that order of mixins is important, it's exactly because of this. This super draw frame leads us here. So it's another manager object which called pipeline owner, handling all part of render objects pipeline. So layouting, composition, paints, and when it's finished and we ready to prepare and we're ready to provide engine description what to show, this part is called from the root view object that we previously created when starting method of our application. It's starting compositing frame. So starting creating an object which will describe what to show. And this object is moving to engine, and engine decompose those objects and create the actual texture and those things converting to every pixel on our screen. But apart from optimization for building, we also have an optimization for layouting. Layouting by itself, it's follow three rules which almost everyone knows, that constraints goes down, sizes goes up, and parents position their children. And so it's the general rule how it's work. And the constraints depends on of course the layout protocol, but for box protocol it's quite simple. It's just amount of space, minimum and maximum height and width. And the answer for this constraint is through the geometry, also size, which width and which height is taken. But Flutter wants to do this also in optimal way. An optimal way means that we, for beginning, we of course need to go through all of them one by one, every node providing constraints and waiting for size and go back. But for every other frame, we expect sublinear performance. So the only small pieces will be updated. Because of this, it will be efficient. But apart from this, there is optimization which help us to cut off some calculation. For example, if child doesn't mark its own layout as dirty, it can cut off calculation if parent provide the same constraints. For example, parent provide these constraints, so take more than this square and less than this square. Child take these constraints, provide adjusted constraints to each child. Child 2 take the size, child 1 take the size, everything fine. And then if parent provide the same constraints, child 1 can stop all those things and do not provide anything below, because it's the same constraint. Nothing has changed. Apart from that, every time when parent layout the child, it's say will it be used size which return back or not? If not, if something changed on the child and child layout, it's do not affect parent at all. So parent provide the size, child calculated things, then child for some reason decide to recalculate its layout. Something happened, and parent doesn't care about this. Child anyway will take size which respect this previously provided constraints. Also, tight constraints is a good optimization. So tight constraints is a constraints which makes allow the only one size. For example, if max width and min width the same, max height and max min height the same, there's only one possible size on those things. And it's also a good optimization to cut off many calculation. And also the last optimization is render object can declare that it's used only constraints that provided from parent for calculated size, nothing else. And in this case, even if parent watch for this child, observe its changes and so on, nothing will be changed after layout calculation without changing constraints. For example, parent says, I observe for your size, and this is constraints. On this, child say, I don't care about anything apart from the constraints, and take this size. And if something happened, the child, for some reason, really out, parent even watching for those size will not affect it, because the constraint wasn't changed, and the child already said, I don't care about anything apart from constraints. So that's almost everything that I wanted to share with you today. So hope this information is helpful for you. And if you like Flutter, so you always welcome on my channel. Uh, you can join it, follow the news, and ask questions. And thank you for your attention. And I'm ready to answer questions.